So edge computing has better latency reduction and real-time responsiveness than cloud computing. One of the major limitations of traditional cloud computing is its dependence on centralized data centers that are often located far from the end user or device. This geographic distance creates latency, which is unacceptable in certain applications like autonomous vehicles that require millisecond level decision making to avoid accidents, smart manufacturing systems that depend on instant feedback loops for quality control, and healthcare monitoring devices that need immediate alerts for life critical events. By processing data at or near the source, edge computing minimizes the round trip time to centralized servers. This makes it ideal for real time decision making, ensuring fast response and improved user experiences. So edge computing has lower bandwidth use. Edge processes data locally and sends only key information to the cloud. It also reduces network congestion and data transfer costs. Edge computing also has higher network efficiency. It is less reliant on distant servers, which means fewer delays. And it also maintains performance even with weak or unstable internet. And lastly, it's scalable and resilient. It distributes processing load across multiple edge nodes, and it enables operation to continue during cloud or network disruptions. By keeping sensitive data closer to its source, edge computing reduces the attack surface and exposure to third-party cloud vulnerabilities. It also allows organizations to apply localized security measures at the device level, comply more easily with data protection regulations, and avoid unnecessary transfer of personally identifiable information. This is what makes edge computing particularly attractive in sectors like healthcare, finance, and government. Edge computing offers cost-efficient scaling. It also reduces reliance on massive centralized data centers. The processing at the source lowers data transport and storage costs. Additionally, organizations can scale by adding edge nodes as needed. Edge computing also has lower infrastructure burden since less bandwidth is required. This means that a smaller investment in expensive network upgrades. It also reduces dependence on high capacity cloud servers and large scale maintenance. It also optimizes the use of existing local resources. And lastly, it has improved flexibility over cloud computing. Edge nodes can be deployed strategically where demand grows. It's easier to support rapid expansion without overbuilding infrastructure, and it's ideal for industries with geographically distributed operations. How does edge computing outperform cloud computing in certain industries? Well, in the healthcare industry, edge computing processes vital signs locally on medical devices or hospital edge servers. It enables immediate alerts for critical conditions without waiting for cloud response. It keeps sensitive health data closer to its source, strengthening both privacy and compliance. Why does it win in autonomous vehicles? Because it provides real time decision making. Vehicles must be able to process sensor and camera data in milliseconds in order to avoid collisions. Cloud latency is too high for such split second decisions. Edge systems and vehicles allow local decision making, improving safety and reliability. Lastly, it's better in Internet of Things and IoT due to its smart infrastructure. Billion of IoT devices generate huge data volumes. Processing locally reduces bandwidth strain and avoids constant cloud communication and enhances scalability by adding edge nodes where needed.